factoring. Okay. All right, so the first one, you have to do the a times c, okay, which is 6x squared times 5 gives you the 30x squared. What multiplies to 30 and adds to negative 17, negative 15, and negative 2? What you have here is correct. Okay, for b, simple factoring, x minus 9 and x plus 2. Excellent. For c, there was a greatest common factor. Hopefully you fixed that middle term with 24. Factor out of 4, and then you're left with v plus 8 and v minus 2. Excellent. For d, greatest common factor is 2x. You're just left with x minus 2, as far as you could go. For e, greatest common factor was x, and you're left with x minus 7 and x minus 9. For f, just one more thing we have to do, and that's it.
It's 3t plus 3.
Keep going.
T plus 4.
Look at these two numbers. What's the greatest common factor?
Oh, 3.
9. Good. You have 9, t plus 3, and t minus 3. Okay, so just one step further. We had to take it. Okay, factor out the 9 in both, because if you left the 9 in there, you would have 3 minus 9 times 3 plus 9, and then you could factor out 3's from both. Okay, so this would be your final answer. All right, awesome. Good job with that. How is factoring this time around? Pretty good? Okay. You will be seeing factoring, and I will include it on a warm-up or a formative, which next class you will have a formative, okay, on this stuff plus 1 or 2 factoring, okay? Then we get into classify if it's arithmetic, geometric, or neither. How can we tell the difference? Yeah.
Where with arithmetic, it's that there's a common number being added or subtracted in between the numbers. If it's neither, then it's not being added by a common number and it's not being multiplied by a common number. And if it's geometric, it's all being multiplied by the same number.
Excellent. Okay. Perfect explanation for all three. What is that common number you're adding or subtracting by? What is that called? Someone else. Yeah, Anton. Adding or subtracting. Okay. Yeah, Olivia. Common difference. The growth factor is for geometric, where you're multiplying by the same number. Excellent. Good. Okay, so 2a, it was neither. All right. You're adding by 2, then adding by 3, adding by 4, 5, and 6, and your next term would be 21. Excellent. 2b, the next term is 52. It is arithmetic because the common difference is what? 3. Excellent. Good. For C, the next term in that sequence is negative 324, which means it's geometric. Okay, if it's geometric, what's the same number? What are we doing? You're multiplying by negative 3. Excellent. For D, it is arithmetic. The next term is negative 2. What is the common difference? Yeah, Julia? For D? Yes, you are adding 8. Thank you. And then for E, it is geometric. The next term is 625. What are you doing? God bless you. Yeah, go ahead. Excellent. Good. Multiplying by 5. Nice job, you guys. Okay. Any questions? Pretty easy, right? To distinguish. Then we get to what we left off last class was a recursive rule or definition, which means you need the previous term in order to find the next term. That's all it means for recursive. So, and all of you did excellent by how you wrote it out, okay? So the recursive definition was you are multiplying the previous number by 2. The next term would be 96, okay? So right next to that or near the numbers, I want you to write the actual definition. Not in words, but looking like a formula kind of. So if we use just a sub n, which is any function, okay, You could change this to f, you could change it to g, whatever you want. It's just the function name. Okay? Then you have a times n minus 1, which represents the previous term, right? Times 2. Okay? That's what a recursive rule looks like. Okay? Then you also include n, which is the term number, has to be greater than or equal to 2 in this case. Okay? And you also want to state, which we could do this at the beginning, what the first term was in this case, was -3. Okay? So when you're writing a recursive rule, okay, when you're writing a recursive rule, you will include the first term given to you, okay, then what's actually happening. So this is the notation you're going to see for a recursive rule, okay? Right? And that's only for, you could find the next one if you have the first term or the previous term, okay? Then for B, and I'll write it right next to it, okay? For B, you're adding 30 to the previous number. Therefore, the next term is 187. Okay? So how you would write this is, and I'll use a different, there, I'll put the first term was 37. Okay? And the rule, whatever I used here, okay? For the recursive, this is what it would look like. So you're going to need to know how to explain it, what you see on the board, and then what I put in terms of a rule. Anytime it's asking for a recursive rule, this is what I want to see. Okay? Definition, you could explain. Rule, this is what it should look like. Okay? Include the first term and what's actually happening. Okay? Then C is also correct. Okay? Multiply the previous number by -6. The next term, and I'm glad you guys made that change or noticed it, should be the last term before you find the sixth term, was -1296, 1296. Okay? So again, if we write this as, and I'll show you many different ways where the first term came first. Okay? And is greater than or equal to 2. You have to know this. You will be marked wrong, too. So that's one thing with this. The terminology is key. Okay? Terminology is key for this, as well as understanding what they're asking for. So I could give you a ton of word problems, let's just say, and then all the questions will be different. Okay? So recursive rule. This is what it looks like. Recursive definition. Yeah, Jonah? No, we're kind of keeping it consistent. If you did X, great, but we've been using N for the next term. The G? Oh yeah, that number doesn't matter. No, no, no. That's just the function name. Just like with function notation, you would see that a lot. Okay? Any questions? Yeah, Ellery. So it has to be greater than, because we can't have a negative number in here yet. Okay? So N is the term number. It has to be greater than term 2 or equal to term 2. Okay? So you're going to see this actually change a little bit today, where they'll give you 0 term, which in a sequence, you can't really have a 0 term, but you could input 0. So you're going to see that as well. Yeah.
So in what way would it be n plus 1? And then, like...
It would not, because n minus 1 means the previous term.
Okay, so there's never going to be n.
Nope, not in this case. Great question. Okay. You will, when you go through, you might see an equation eventually with the plus 2, but not in this notation. Will always be n minus 1. Okay. So this would always be standard. Okay? Questions? All right, good. All right, let's go through this. Okay, for number 1, for all of these, find either the growth factor, another name for it is common ratio, rate of change, or another name for it is common difference. Which one of those represents a geometric sequence? Which terms? Yeah, common ratio. So this is our geometric. Good. And then we have our arithmetic. Okay, so for number 1, Anton, what do we have? Okay. So you're adding 10 to the previous term, right? Excellent. Okay. Common difference is plus 10. For number 2, starting at 10, each new term is 5/2 less than the previous term. Okay. What would this be? Okay. Yeah, Mike. Okay. Why? Mm-hmm. Yeah. So your common difference then, would it be plus 5/2 or minus 5/2? Good. Okay. Excellent. Common difference, arithmetic. You are subtracting 5/2 from the previous term. Excellent. Number 3. Okay. Number 3. What do we have? Go ahead, Luce.
Geometric.
Yep.
The growth factor is
Excellent. Good. Growth factor is 1/2. Excellent. So we have our geometric here. Perfect. Okay. Number 4. This is the recursive rule. That's what it looks like. That's the recursive rule. What do we have here? Go ahead, Julie.
I'll go like
Good. Geometric is the growth factor. Excellent. Okay. Now number 5. Okay, we have a table. What do we have here? Go ahead, Olivia. Yep. Mimic. The common difference plus 0.1. Excellent. Okay. Yeah.
Wait, I'm confused for 4. How's the? I just. Oh, okay, never mind. Actually,
You see it now?
yeah, I did.
It's okay. It's okay. So that's one thing with this, and I'm glad you brought that up. There's a lot of stuff going on just in one formula, I guess, or rule that you want to look at. So just be careful. Typically, and this could change. So you could see it this way, or in some cases, they might write it like this, okay? Which just throws everybody off because it's been the same all the time, and then they'll just switch those two. So just be careful. In a recursive rule, you're looking at either what is multiplied or added or subtracted as well. Okay? Any questions? Good. All right, this is where it's better on your pages. This is where you're matching. However, there is a difference, okay? There is one sequence that will not match a definition, okay? The one sequence that does not match a definition, you are writing a recursive rule for, okay? So one sequence that does not have a match, you're writing a rule. So it should look similar to this, okay? Then there is a rule that does not match a sequence. You're finding the first 4 terms, okay? Does that make sense, you guys? All right, go ahead with your partners. You could draw arrows, you could write letters next to it, whatever you want to do. Match a sequence with a definition. Go ahead. All right, let's go through matching, okay? You have sequences on the left, recursive definitions on the right. So for number 1, which one does that match to? Yeah, geez. Good, to the last definition, so M. Excellent. Okay, how about number 2? Yeah, Julia. L. Good job. Excellent. How about number 3? Go ahead, Michael. J. Good. Right across. Okay. How about number 4? Go ahead, Bella. Okay. Good. Okay. And then number 5. Number 5. Number 5. Number 5. Number 5. Yeah, Caitlin. D. Good. Okay. Did 6 match with H? No. Okay. So for number 6, we have to write a definition very similar to the right-hand side. Choose whatever letter you want. Let's see, F wasn't chosen. So if we do F of 1 is equal to 18, okay, because you have to have your first term. What is happening here? You're adding 2. Good. So F of n equals good. Okay. And if you noticed, they did multiplication in the front and then addition and subtraction behind. Okay. So depending whatever function name you used, okay, it's going to be the same throughout. All right. All right. So H wasn't used. What are the first 4 terms of the sequence? Go ahead, Luce.
315, 75.
Excellent. Good. And again, they're telling you your first term is 3, and then you're multiplying the previous term by 5, okay, each team. Excellent. How many of you guys got this? Pretty easy, right? Okay, cool. All right, now we're given a recursive sequence. Okay, there's 2 things. Recursive definition. You are listing the first 5 terms of the sequence, then graphing, okay? Do not forget to label what your x-axis would be and what your y-axis would be, okay? So the first 5 terms, they are giving you the first term, which is what? 2/3, okay? Now, what type of sequence are you going to have? Yeah, Jason. Geometric, because we're multiplying, okay? So you're starting with the first 5 terms. Here's your first term, then you have to find the next 4. Graph it, okay? Then you and your partner in 2, which one doesn't belong? There's no right or wrong answer here. It's a discussion. Can you, God bless you, distinguish which one does not belong? All right? Take about 3 minutes, 1 and 2. Just going around, okay? We need a little recap of multiplying fractions, okay? You start with your first term, which is 2/3, okay? Then the rule is you take your previous term and multiply it by 3/2, okay? So here, when you're multiplying fractions, we just multiply across. You could do this without a calculator, okay? So 2 times 3, 6 times 3 times 2, which gives you 1, okay? Then we take our previous term, multiply by 1, we should get what? 3/2. Then we take 3/2 and multiply by 3/2 to get 9/4, good. Then we take 9/4, multiply by 3/2, and what do we get? 27/8, good. Okay, so the first 5 terms starts with term 1, which is 2/3, term 2, term 3, term 4, term 5. You do not need a calculator for this, okay? The calculator sometimes screws you guys up, okay? In terms of parentheses, do you need parentheses or not? Okay, we should know how to multiply fractions. So, how many of you did eventually get these? Okay, good. So from here, when you graph, okay, you should have term number, okay, and the value, okay. And again, you could do increments however you want. Okay, I think I skipped over one, as long as you're consistent, okay, 1 through 5, and then, it's hard to see on here, okay, and just plotting points, that's all we're doing, we're not really connecting anything. So, 1 2/3, 2 1, again, hard to see, 5, somewhere up here. Okay, so you see this graph. And again, it's going to look better on my key or in front of you. All right, how many of you ended up getting this sequence? Okay, 1, 3/2, 3/4, and 27/8. All right, then the last one here. Which one does not belong? Again, no right or wrong answers. What are some explanations? Yeah. Okay, so this notation is different, right? Okay, so we're not given the first term. Okay, so we notice f of 0. Anything else? Yeah, Mike. Okay. Okay, so they usually say 2, so we're still on the same one. Okay. What else? Is there others you would say do not belong? Yeah. Why? Right, so these are the two, if you were going to argue that did not belong, this one's apparent because we've been starting with f of 1, right, or g of 1, whatever it might be. But they do show you f of 0. If you notice, this notation changed as well, okay? But then if you look at D, everything has been either arithmetic or geometric. This is now different, n squared. Okay, this is now different, n squared. So you could argue that doesn't belong. Okay, so there was no right or wrong answer, it's just your explanation as to why you think C doesn't belong, explain why, or D. Okay, questions? Now, every time I give you notes, there is a summary at the end of every note. Okay, the summary is key information that we should be reading on our own. Okay, we're going to go through this one because there is important information and then you guys are going to get to practice. So here are some ways to represent a sequence. Each representation gives a different view of the same sequence. So you could have one sequence represented a few different ways. The first way is just a list of terms, what we've been dealing with, list of terms. The second way is a table. Okay, you could represent a sequence. The next is a graph, which we saw. Okay, and what would be the last way? We have graph, we have table, we have equation. Oops, just gave it. Yep. An equation would be the last one. Okay, in an equation we could define sequences. So all 4 of these ways will represent a specific sequence. Okay, and you could have the same sequence represented 4 different ways. Okay, you just have to pay attention to the language. All right, so we are going to get into practice in your green packets. We're finishing it up. 5 and 6. Then you have Delta Math. And Delta Math you get through ClassLink. Yep. Whatever you don't finish for either or would be homework. Okay? So these are both